Right, that's great. Again, hold your questions. I think it's wonderful work seeing Matchmaker kind of deepen and develop with the new Search API. So we have 3 more to go. Stay with us. Write down your questions. So next up is data use ontology, which I think is Melanie and Moran, yes?
Thank you. All right. Okay. Pointer. All right. Thank you, everybody. I'm the Melanie half, and I'm here with my colleague Moran from the Broad. We're really happy to be here today. We're really excited to tell you about the data use ontology, GEO, and the work we've done with the data use and researcher identity workstream over the past year, and where we're hoping to go with you over this coming year. All right, this works. So what's the challenge we're trying to address using GEO, the data use ontology? Well, manual review of data access requests currently does not scale. We know that a lot of genomics and health studies, for example, have restriction on access to the data. Example of such restriction is this data is available if you want to do cancer research in a non-profit setting. When a researcher wants to query for that data, those queries go through a data access committee, which is a group of people manually reviewing each of those data access requests. If you're a researcher for a private company, you will get denied. If you're a researcher for a non-profit organization, this request will be approved. What do we know of that process today? We know that those data access requests are growing exponentially. This is a graph showing the data access request over the past 10 years for DB gap. And we know that there's a gap we need to close and help with manual review. The second component to that process is the work that's done by my colleague on the researcher ID side, which we will present just after this presentation. So almost there. What is GEO going to do for you when you want to request data? So the first step is being able to classify the data across repository consistently, unambiguously, using the data use ontology. So here's an example of a dataset catalog where each of the datasets has been annotated. Is this going to work? Each of the datasets has been annotated with a GEO code representing a restriction. So we are human and we show you human labels, but it's an ontology. Everything in the back end is code and numerical IDs. So each of those datasets has this restriction, and that can enable discovery when researchers, on the other hand side, try to find data compatible with their specific research purpose. And the general vision where we're hoping to go is having that little click button at the end where you can just request access to the dataset you just searched for, and you automatically and almost immediately are granted access to those datasets. Why does the ontology help, and how is the ontology help? So the power of the ontology is when you have the dataset which is annotated. This is an example of a data repository, different studies from A to G, annotated with different type of consent. A researcher is coming in, studying melanoma. Let's take a simple example, wants to know, hey, what data do you have and how can I get it? You can really see how an algorithm, an automated algorithm, not a manual reviewer, can really identify the proper position in the hierarchy of the ontology and then just walk all the way up. Walk all the way up, matches the studies that have the corresponding consent codes and grants access to those. Will not grant access to those that don't belong to that walking up path. GEO did not originate right now. GEO builds on other efforts that have been done by amazing people and collaborators, and we're still working with those people today. Very early on, the NCBI DB gap had a controlled vocabulary of consent codes on their data sets. There was an amazing work that was done by Stephanie and NCBI, EGA, many other people on trying to formalize those consent codes and have a consensus list of those that are being used by the community. Tony, you've heard about Tony a little bit earlier. Tony and the Adam workstream have developed an automatable data discovery matrix, which we're also leveraging. And we have created in 2017 a version of the data use ontology which builds upon and formalizes those pre-existing projects. This is available under our GitHub repository. And over the last year, we have expanded on those initial projects. We've added new terms, updated definitions, and this was done to better fit the needs of the driver projects we are working with and which Moran will describe in a little bit. This is an excerpt of the Duo as it is today in our GitHub development branch. I'm not going to go through the details. You can see that there's a hierarchy that algorithm can leverage, and you can see that each term, as I mentioned earlier, has a unique ID. We support versioning and all those things. We do consistency testings. Come and talk to me later. I love talking about that. Each term has a label, a human-readable label, has a definition, and this is really for human users when you want to tag your data set or when you want to request access. You have that common reference that can be understood to tag using Duo. This is all done using W3C standards. We're using the Ontology web language. It's human-readable here. In the backend, it's all numerical and logical axioms. It is all under GitHub, and it's a very open community. We invite collaboration. And with this, I'm going to hand over to Moran, who will tell you more about the driver projects we worked with, the changes we've made, and how practically Duo is used today and how you can use it for your own project. Thank you.
So thanks, Melanie. Thanks, everyone. So as Melanie told you, some of the focus of this year with DUO was to basically make sure that we have terms to support a discovery query. So as Melanie described, we have all of our terms on a GitHub repository that you can use for your services. And we extended it with documentation that gives examples of how you can use these terms to represent both research purposes, requests for discovery, as well as the restrictions on data sets. So you can check that out and see examples of how we're using it. Here are some examples of a couple of driver projects that are adopting our ontology. So I think Thomas already gave this slide, which was great. So EGA has been using consent codes with data use ontology terms to label data sets on the EGA repository. So you can see both the labels and the source of that basically brings the definitions. In a similar way, so Bob Grossman's team from UChicago is part of our efforts on the NHLBI data stage and the NIH data commons, has been labeling TOPMed data sets with dbGaP data use restrictions, again with DUO terms. So what you can see here in the next slide is that that they're using basically the new definitions as well as the terms from the ontology. So that was representing how you describe data use restrictions on data sets. Now let's go to the other side. How do you represent research purposes, right? Because we want to enable a discovery query. I'm coming to a place, I want to say what I want to study, and we want to return back the data sets that are compatible. So this is the All of Us researcher portal. When a researcher starts a project on the All of Us researcher portal, they have to describe what they're going to study. And they're actually describing that with data use terms. So again, we're using DUO for that. So for example, you can say that you are going to use it for a commercial purpose, or you're from a commercial purpose entity, or you're developing methods and so on. And last, the ontology now is rich enough to support a query match in the duos algorithm that we developed at Broad. So the idea here is what I'm showing you is a catalog of data sets at Broad. And you can come into the catalog and describe your research purpose. This description is going to be mapped back in the back end to the ontology. So I can say that I want to study atrial fibrillation and I want to develop methods. We're coupling DUO here together with the disease ontology. Because we're coupling these two ontologies together, we can apply a search and then get back returned data sets that have labels that are compatible with that. So if I want to study atrial fibrillation and develop methods, I'm going to get back data sets that are allowed for health biomedical disease or general research use, as well as data sets that are allowed for cardiovascular disorders research, because atrial fibrillation is a type of a heart disease, a cardiovascular disorder. So this basically just tells me which data sets are available for that study, and we can do that today with DUO and the DUOS algorithm. So I just want to mention that there's public APIs for this implementation. And in this coming year, we're collaborating together with U Chicago as well as UCSC to implement it in data explorers that they are implementing. So what's next for DUO? So we're in the final processes of getting our next version of DUO approved as a GA4GH product. We have the last version on GitHub as well as our documentation. Please come, review, and comment. And we're going to work together with more partners on new adoption. I was mentioning already the TOPMed datasets, as well as we're discussing with the Beacon how we can incorporate that with them and with Australian Genomics. And please join us if you are interested in adopting this resource. We're going to also make a governance group to have a formal process for approving changes. With that, I want to thank everybody who helped developing this ontology through the evolution of the project, as well as Melissa, who has been managing our Access product line and really making everything happen, and everyone who helped us adopt the standard this year. Thank you.